Hello everyone, and welcome to this series on financial mathematics. In this series, we're going to tackle a lot of the problems that people encounter when it comes to finances, whether it be mortgages, loans, interest payments, checking accounts, savings accounts, banking, money allocation, money management, bill payment strategies, and so on. So, math has so many tools that will allow you to analyze these with certainty and also in times of uncertainty as well. So we'll try and go through as many of those as possible. So today I just want to introduce some of the basic ideas associated to financial mathematics and introduce the concept associated to the time value of money. So let's start off with a very basic question that is very easy to understand. If we have $5 today and $5 tomorrow, did we gain money, lose money, or neither? So this is a very fundamental question, and it actually has a lot to do with the time value of money. So what I'm going to do is I'm going to create a timeline, and when it comes to financial mathematics, timelines are very, very important. So this is the timeline associated to T. Let's assume that we have 2 points of interest here. Let's assume that this point is going to be represented by S subscript 0, and this is going to be ST. So S0 is going to correspond to the initial amount of money. Some people also call this the principal, Principle, so the principal amount of money or the initial amount of money. And this particular value, ST, this is the amount of money at time t, where t is typically greater than or equal to 0. Right? So if we have $5 today, so that would be S0, and $5 tomorrow, that would be ST, where T represents, for example, 1 day in the future. Are these two things, greater than or equal to, less than or equal to one another? Well, it really depends on your view of time, your view of money, and the relationship between these two entities. Most of the time, people will view time and money as equal or similar ideas. In particular, with the very cliche statement, time is money. So if we think about this particular question in a little bit more of an open-minded viewpoint, for example, let's assume that this is S0 today. For example, I have $5 today. And let's assume after 1 day has passed, that's going to give us, for example, S1. And then we have $5 here. Let's assume that the value of 1 day to you is equal to $2. Right? So if the value of 1 day is equal to $2 and you have $5, then you should have $7 at this particular time period, right? So we should have $7. So we should have $7 because we started with 5. 1 day has passed, so we should have made $2 over the course of that day, but we only have $5. So where did that $2 go? I don't know, maybe you bought a coffee or something like that. So since we should have 7, but we only have 5, that means we lost money from this perspective, right? But if the value of 1 day was $0, then $5 today and $5 tomorrow are equal to one another because you do not value time from that particular perspective. Right? Now, there's this very interesting idea here. The value of 1 day is equal to $2. Some people will agree with that. Some people will disagree with that. And some people will say, time is invaluable. You can't put a price on time. Regardless of how you view the value of a particular day, regardless of that number, this can be, or pretty much is always, subjective. So this can be subjective depending on the person. So if it's subjective dependent on the person, well, how will you decide how much money you will pay a person? Because everybody is going to view time in a different way. So what we usually do, and this is just one solution, it's maybe not the best solution, but it's one way to solve this problem, is we can take time value and define it in terms of what we call interest. So time value, how you view time, is mapped to interest. So it's a way of valuing time, and either you agree with this value or you don't. Maybe this interest rate is too high. Maybe the interest rate is too low. Regardless of how you view it in terms of large or small, it is one way to value time. So pretty much when you have a loan, there's an interest rate associated to it. Do you think it's high? Do you think it's low? Do you think it's okay, right? So you think about that question from your perspective of how you value time and see if you agree with that particular evaluation of time or not. So how exactly would one define interest? So some people will define interest as the cost or the price, depending on the angle, of borrowing money. The cost or price of borrowing money. And this is typically based on the principal amount borrowed and other factors such as inflation, such as the weather, such as, do you plan to buy things over, the span of the life of that loan, or what have you, right? Because you sort of have to make up that time if you lend money, and hopefully, they pay you for all of the money that you could have made in that time period, right? So that's pretty much the idea of interest. And there's one common or one simple way of defining interest, and that is sometimes referred to as simple interest. So a simple interest rate, and I'm going to represent this by I subscript S for interest rate simple. There's going to be several different interest rates that we're going to explore, is one that depends only, so it only depends on the principal amount borrowed or invested, depending on your angle. So with that idea, let's actually look at a real-life example of how simple interest rate actually works. So let's suppose that you borrow $500 at a simple interest rate of 7.3% per year. How much money will you need to pay back after 7 months? Okay, so let's draw a little timeline to sort of see what's going on in this particular problem. So what we have here is a timeline. Let's assume S0 is here. So S0 is corresponding to $500. That's how much we have. And let's draw a full timeline all the way down to 1 year. So I'm not going to write S1 only. I'm just going to write S1 year because there is a bit of ambiguity if you just use subscripts with just numbers, right? So it depends on context because 1 could correspond to 1 second, 1 month, 1 year, 1 eternity, 1 cat, 1 something. We don't know, right? So sometimes it's useful to put the unit there just to be sure that everyone is on the same exact page. So we're giving that our simple interest rate is 7.3% per year, and that unit is very, very important. So after 1 year, if we were to borrow it for 1 year, we would have to pay back the $500 plus their time evaluation for an entire year, because everybody values time a little bit differently. They value things at 7.3% per year with respect to the principal for which you have borrowed. So you should have to pay back 7.3% of 500 back in terms of interest, right? So that's how much you would have to pay back after a particular year. So if we do 500 times 7.3% times 500, what will we have? So that means after 1 year, so S 1 year, will be equal to, again, 500 plus 0.073 times 500, and that's going to be coming around about $536.50. Right? So that means they value a year somewhere around $36.50 for the entire year period, right? But keep in mind, we are not borrowing this loan for a full year. We're only borrowing this loan for 7 months. So instead of paying $536, we should be paying something a little bit less than $36, because $36.50 is for a full year. So we should be paying, for example, 7/12 of $36.50. So how would that look like in a timeline perspective? So if we're looking at things in terms of months, then that means we need to change our timeline up a little bit. So S0 is going to be there. And then 1 year is now 12 months. And then we're going to have a bunch of increments. So we have S1, S2, S3, S4, S5, 6, 7, 8, 9, 10, 11, and finally 12, right? So we have S1, S2, S3, S4, S5, S6, S7, S8, S9, S10, S11, and S12. So we plan to pay back this loan at S7, right? So our goal is to borrow 500 at time t is equal to 0. If we borrow it for the full entire year, then we're going to be paying back $536.50, but we're not. We're going to be paying it off at this particular time here. So this point is going to be equal to what? So S7 will be equal to our principal amount, $500, and then we're going to have our 0.073, so that's our yearly simple interest rate, but we only want 7/12 of that, because 0.073 is per year, not per month. And then we're going to multiply that by 500, and that's going to give us our value at S7. So once we actually calculate that, that's going to be equal to what? So that's going to be equal to approximately 500 plus 2129. That's an approximation, of course. So therefore, we will be paying approximately $521.29 at that particular time period. So $521.29 at 7 months instead of $536.50 for the entire year. Right, and you can argue this for any number of months less than 12, and you can argue this for more than a full year if you want to as well. So I actually want to look at this formula in a little bit of analytical manner, because notice we have a 500 there and a 500 there as well. So we might be able to make this math a little bit more general with ease. Again, our P stands for our principal. And our principal, sometimes P is denoted by S0 depending on the context. And again, IS is going to be representing our simple interest rate. And obviously that's going to be for some period. And in particular, when we say period, we're talking about time period of length. Let's assume the length of that period is of capital T. Right? So once we have that, then that means ST, which is the amount of money at time t, is going to be equal to our original plus the original times our simple interest rate times the amount of time that has passed. And keep in mind, IS is in terms of capital T, and little t should be in the same exact unit. So notice that S0 is a common factor for this particular expression. So we're going to have ST is equal to S0 times 1 plus IS times T. All right? So again, T is going to be the amount of time that has passed, and IS is going to be the simple interest rate for some period. And keep in mind, they had to be the same unit. So if you're borrowing in terms of months, IS should be in terms of months. If you're borrowing in terms of years, IS should be in terms of years as well. So now that we have this general structure associated to simple interest rate, let's look at an application that actually uses this formula to figure out which type of account we should invest in based upon different interest rates and different lengths of times. Let's assume that you invest $500 into an account A at a 7.5% simple yearly interest rate for 3 years. And let's also assume that you invest $800 into an account B at a 6.8 simple yearly interest rate for 4 years. Which makes the most money during the life of their investment? So using the formula that we just came up with for simple interest rate for a given period of length capital T, what will we get? So if we use that quick strategy, what we're going to have here, so we have, for example, SA at time T is equal to 0. This was equal to $500. The simple interest rate for that particular account A was equal to 7.5%, which keep in mind is 0.075. And the length of time that we keep that in there, and keep in mind that's per year, the time that we keep it in account A was going to be equal to 3 years. So since both of them are in terms of years, we don't have to do any conversions. And the amount of investment into account B was equal to $800. So of course a little bit more upfront investment. And the simple interest rate for account B was equal to 6.8%. So it's less than A, so it's not going to make as much money as fast, but we are investing a little bit more money into it, and we're also going to be investing it at a longer period of time. Keep in mind 6.8% is 0.068, and that was a yearly interest rate per year. And we were keeping our money into account B for 4 years instead of 3. Right? So which one will return the most money when those times, TA and TB, expire? So 3 years and 4 years, respectively. So using our relation, what we're going to have is what? So S for A after 3 years is going to be equal to, so the principal amount, 500, times 1 plus our interest rate, 0.075, times the length of that investment, which is going to be 3. And similarly for B, so SB for 4 years, is going to be equal to the principal investment into that account, and then 1 plus 0.068 times the life of that investment, that's going to be equal to multiplied by 4. And then once we work out that math, we're going to have approximately equal to $612.50. So we have received $112.50 over the course of 3 years for account A. And for that, we're going to receive $1,017.60 approximately. So that is returning about $217.60, right? So, in particular, so the interest, which I guess you could look at as in terms of profit. So this is $112.50, and then $1,017.60. That's going to be a $217.60 return on investment, right? So we're obviously getting more money from account B than we are in account A, right? So which one would you invest in? So if you argue that, okay, we get more money from that particular account B, then maybe we should invest in B. But keep in mind, we have to wait longer for that, right? So we have to wait longer for this, right? So maybe what we can do is withdraw money out of the account B maybe a year earlier and compare that to A. Or maybe we can keep the money inside of account A for another year and then compare that to B, right? So it really depends on how you value your time and when you need that return on investment for any big purchases, right? And I'll let you sort of analyze that problem on your own. So that's just a quick introduction to the time value of money and financial mathematics. So I hope to see you for the rest of this journey, and in particular, the next video. Take care.